Today we'll be looking at how to solve systems of equations by graphing, substitution, and elimination. This is the Algebra 2 prerequisite number 2. So what is a system of equations? Well, a system of equations is when you have two or more equations using the same variables. The solution to a system is a point that satisfies all of the equations. This point will be written as an ordered pair. There are three ways to solve a system. You can graph it, you can use substitution, or you can use elimination. In graphing, there are three types of graphs you may see. You could see intersecting lines, which would give you one solution. You could see parallel lines, which give you no solution because the lines never cross. Or you could see coinciding lines, which is one line directly on top of another, and this gives us infinite solutions. So here's an example. Find the solution to the system of equation by graphing. Well, the only types of lines we know how to graph are in slope-intercept form. So we're going to take this first equation, 2x minus y equals 4, and we have to solve for y. So we're going to subtract 2x from both sides, and we're left with negative y is equal to negative 2x plus 4. Then, because we have a negative y, we're going to divide each piece by negative 1. And when we do that, we get y equals 2x minus 4. Now we can graph this. Our y-intercept is negative 4, and then the slope is 2 over 1, so we rise 2, run 1. Rise 2, run 1. For our second equation, it's already in slope-intercept form, so we can go ahead and graph it. Our y-intercept is negative 7, so that's where our line is going to start. And then it's going to rise 3, run 1. Rise 3, run 1. And you keep going until you find the intersection. This one intersects right here. So that means that the solution to this system of equations is 3, 2. You have to write your solution as a point. Another way to solve systems is through substitution. When you're solving by substitution, at least one of the equations must be solved for x or y. So in our first example, we have to have one of these solved for x or y. Well, the easiest one to deal with is the second one. We can get this solved for y very easily by adding 5x to both sides. So when we do that, we get y equals 5x minus 16. And now that we know that this is what y equals, we're going to take that and plug it into the y in the other equation. So then we have 3x minus 8 times 5x minus 16 equals 17. Now we're just solving an equation. So we distribute our negative 8, and we get 3x minus 40x plus 128 equals 17. We combine our like terms. 3x minus 40x is negative 37x. And then we keep our plus 128 equals 17. We subtract 128 from both sides. And we've got negative 37x is equal to negative 111. Divide by negative 37 on both sides and you get x equals 3. Now, we're not done because we have to have an ordered pair. So we take that 3 and we plug it back into one of our equations. I chose this one because the y is already solved for. So when we plug it in for that x, we get 5 times 3 minus 16. Well, 5 times 3 is 15, minus 16 is just negative 1. So our ordered pair would be 3, negative 1. In our second example, the easiest one to solve for would be this x. So we're going to subtract 2y from both sides, and we get x equals 8 minus 2y. Now we're going to take that 8 minus 2y and plug it in for the x in the other equation. So then we have negative 4 times 8 minus 2y minus 4y is equal to negative 12. We're going to distribute our negative 4, combine our like terms, and solve for y. So we're going to add 32 to both sides, and we get 4y is equal to 20. We divide by 4, and y equals 5. Now, the solution has to be an ordered pair, so we have the y value, but now we need the x. So we're going to take that 5 and plug it in to one of our equations. I chose this one because the x is already solved for. So we get 8 minus 2 times 5, which is 8 minus 10, which equals negative 2. And when we put it in an ordered pair, it has to be the x value first, then the y. So it's negative 2, 5. The final way to solve a system is through elimination. Your goal is to get one of the variables to have the same coefficients using multiplication, and then add or subtract to eliminate that variable. So here's our first example. We want to see, do any of our variables have the same coefficient? So this x, they both have 8s. So we don't have to multiply to get anything the same. So since they're both 8, we need to add or subtract to eliminate that variable. Well, if we add, negative 8 plus 8 is 0. And so, since our signs are the same, we go ahead and add them, and we get negative 8 plus 8 is 0, 2 minus 1 plus a negative 1 is 1, and 22 plus negative 19 is 3. So this one is already done. We get y equals 3. Now we have to take that solution and plug it into one of our equations. In this one, I plugged it into the top one. So then I have to solve for x. Negative 8x plus 6 equals 22. Subtract 6 from both sides. Negative 8x is equal to 16. Divide by negative 8, and x equals negative 2. So my solution is negative 2, 3. In the next example, again, our x's have the same coefficient. But if we were to add these, then we would get 4x. So we don't want to add them. So since our signs are the same, we're going to subtract. So 2x minus 2x is 0x, so we don't write it. 6 minus negative 1, be careful here. This negative negative makes a positive, and you get 7y. And 10 minus 3 is 7. We divide both sides by 7, we get y equals 1. Now we have to take that and plug it back into one of our equations. I plugged it into the first one. So 2x plus 6 times 1 equals 10, which is 2x plus 6 equals 10. Subtract 6 from both sides, and you get a 2x equals 4. Divide by 2, then you get x equals 2. Now we write it as an ordered pair. The x value comes first, which is 2, and then the y value 1. In our next example, we don't have any matching coefficients and variables. So we have to decide, what can we multiply by to get something to match? Well, if I take this top equation and multiply it by 3, I can get the y values to match. So I took the 9x and multiplied by 3 and got 27x. I took the 5y, multiplied by 3, and got 15y. Negative 23 multiplied by 3 and got negative 69. So now these match. My signs are different. I get a negative and a positive 15, so I want to add them. So negative 6x plus 27x is 21x. The y values cancel because negative 15 plus 15 is 0. 27 plus a negative 69 is negative 42. I divide by 21 on both sides, and I get x equals negative 2. Now, I take that and plug it into any of my existing equations from above. I'm going to plug it into the first one for simplicity's sake. So now I replace the x value with the negative 2, and I get 9 times negative 2 plus 5y is equal to negative 23, which is negative 18 plus 5y equal to negative 23. Add 18 to both sides, divide by 5, and you get y equals negative 1. Don't forget to write the solution as an ordered pair. And for my final example, I have 4x plus 2y is equal to negative 6, and 14x plus 7y is equal to negative 21. So I want to see if there is something that I could multiply by to get both of them to be the same. Well, I can't take 4 and multiply by 14 to get anything. And I can't take 2 and multiply by something to get 7. So in this one, I'm going to try to get my y's the same. So I'm going to multiply the top one by 7 and get 28x plus 14y equals negative 42. And I'm going to multiply the bottom one by 2 And here I get 28x plus 14y equals negative 42. So I wanted the y's to match, so I multiplied them by the coefficient of the opposite equation. Now I have matching coefficients with matching variables. So because of this, I have matching signs, so I'm going to subtract, and I end up with a 0 equals 0. When this happens, it's a true statement, so it's infinite solutions. I know that was a lot, but now try on your own. Determine which way you want to solve it, and then solve it. If you choose to graph, please ask for graph paper. Pause the video and try each one, then hit play to see the answers.